Section 7-5, Factoring Polynomials, part of Chapter 7. You'll see a variety of pictures on this page indicating where we're going. We have been doing this already in Chapter 7 in the first couple of sections. And basically we now know that these are polynomials. They're all varieties. You've got trinomials, binomials, and a monomial. And this is considered what we're going to be factoring. So as we look ahead, you're going to see that there are some definite rules around factoring, and there's some patterns and recognition of patterns that happen. And this page, it shows you all the various patterns and how to factor polynomials based on certain factors within what you're looking at or what you notice. On this next page, you'll notice that I have indicated a standard form polynomial. You'll notice that the first term is the square term. Then we've got a middle term, which is the 10x. And lastly, we have the constant. If I was going to ask you to build this using algebra tiles, we would be doing the following. We'd be looking at an x squared tile in the lower left-hand corner. And I know that it's an x squared tile because we have an x and an x. And I'm going to continue to build, and you'll see the result. You're going to notice as I've built the algebra tile representative that you've got the x squared again in the lower left-hand corner. And you're going to notice that I put 8 x tiles on the right-hand side, and going up I did 2 x tiles. And then I filled in the rest with unit tiles. So if I take a look, on the bottom I've got x plus 8. And on the side, or the height of my rectangle, I have x plus 2. And one of the things I want you to remember that x plus 2 and x plus 8 are factors. So I could actually rewrite this as x plus 2, meaning the height, times my base, x plus 8, is going to give me the total area, which if I were to add up all of the factors or all of the algebra tiles inside my rectangle, I would have 1x squared plus, count up how many x tiles I have. I've got 10x tiles, and then if I count up the unit tiles, I have 16. And you're going to notice that this is the exact polynomial that we started with right up there. So please remember that when I want to solve a polynomial, I need to have my polynomial in factored form. So that way we can solve it by setting it equal to 0. And when we do that, we would find the x values. Again, this is just a review. I would set both of my factors equal to 0. And therefore, I would be able to solve for x for both of these, and I know that x could either be -2 or x could be -8. And those are considered my roots. So in this section, though, we are going to be looking at how to factor polynomials. And this time we're going to go from standard and we're going to turn them into factors. And there are a couple of different ways that we can do that. I like to use algebra tiles on the box method, but there's also a method using factors. So we're going to go ahead and get started, and I'm looking for the most efficient way to be able to factor. So I've got a polynomial in standard form, x squared plus 10x plus 16, and we're going to be asked to factor this. So the very first thing, as I went over in class, is we are going to draw a rectangle. And within that rectangle, we are going to make 4 rectangles, or you can look at them as being window panes. And what I am going to do is in the first lower left-hand corner, I'm going to put my x squared tile. And I want you to remember that when I have an x squared tile, my side lengths are x and x. Again, I want to point out in my standard form that I have got a coefficient of 1 in front of my x squared, and notice that both of the signs in my standard form are positive. So I'm adding 10x and adding 16. So what I'm going to do is in this very last rectangle up here, diagonal from my x squared, I'm going to put my last term. So my last term goes in right there. Then my first term, again, goes in the lower left, right there in the gold box. And now what I'm going to do is I'm going to draw a diamond. And in my diamond, the very first thing I'm going to do is I am going to multiply x squared and 16x. And that, when I multiply that, that's going to go in the top of my diamond. So I'm going to write 16x squared. Then what I'm going to do is I am going to take my middle term of 10x, and I'm going to put 10x right below my 16x squared. So now I've got two parts of my diamond. And as I mentioned in class, what we want to do is we want to use the pattern of A and B on either side, and I'm going to multiply A and B together. That's going to be my top of my diamond, and my bottom of my diamond is going to be A plus B. And we follow the same pattern every single time. So now I know that 10x is when I have A and B added together, and at the top I've got 16x squared is when I have A and B multiplied together. So I'm looking for two values that when I add them together gives me 10, and when I multiply them gives me 16. And I know that those two values are 8x and 2x. So I've got 8x and 2x, and both of those values are going to be now placed inside my rectangle. I'm going to place my 8x right here, and I'm going to put my 2x on the bottom. Later on, you're going to notice that it is going to matter where you place them, but for right now, because my coefficient is 1 on the x squared, I can place them any place. I want you to do, though, is note that when I look at 8x and 16x, what is the greatest common factor between 8x and 16? Well, I can say the greatest common factor is 8. And I'm going to do the same on the bottom. What is the greatest common factor between x squared and 2x? Well, it's x. Now I'm going to look on this side. I'm going to ask myself, what is the greatest common factor between 16 and 2x? Well, the answer is 2. And they're both, it's positive on both sides. So you're going to notice that I now have my two factors on either side. I have x plus 8 and I have x plus 2. And those indeed are my factors. And I can verify that by making sure that I multiply x times x to get x squared, x times 8 to get 8x, 2 times x to give me 2x, and 2 times 8 to give me 16. So now I'm going to go ahead and I'm going to write my two factors, x plus 2 times x plus 8. And I know that that is equal to x squared plus plus 10x plus 16. So that is, to me, the best way to factor. It's consistent. I always notice that I'm going to multiply x squared and 16 together to get my value at the top of my diamond. And I want you to notice another important thing that I didn't point out, that when I multiply 8x and 2x together, I also get 16x squared. So let's look at another one. So for this one, we have x squared plus 9x plus 8. And again, I'm going to start, the very first thing I'm going to do is I am going to draw a rectangle. And in my rectangle, I'm going to make 4 rectangles within it. And the very first term is going to go right there in the x squared, very first term. Goes in my lower left-hand corner of my box. I'm also going to take my constant term and it's going to go right there in the upper right-hand corner. So I'm going to write 8. Now what I'm going to do is I'm going to continue by drawing my diamond. And I'm going to take x squared and 8 and multiply those two together, and I get 8x squared. Now in 8x squared, right below it, I've got another value that I can place, and that's 9x. So my middle term always goes in the lower part of my diamond. My 8x squared comes from multiplying x squared and 8 together on the diagonal, and that places right there. Then again, I'm going to remember that my pattern for my diamonds are always A, B. So I multiply my two values. At the top, I have A and B at the sides, and then I add A and B together. So I'm looking for two values that when summed together give me 9x, and when I multiply them gives me 8x squared. I know that I've got 8x and 1x when added together gives me 9x, which therefore now knows that I can place my values into my rectangle. So again, I'm going to choose to put 8x right here, and I'm going to choose to put 1x down in the lower right-hand corner, and now I'm going to go ahead and I am going to factor. What am I going to factor out? I'm going to factor out the greatest common factor. So I'm going to look, first of all, I'm just going to confirm 8x times 1x gives me 8x squared, and x squared times 8 gives me 8x squared. So now let's go ahead and factor. I'm going to factor out the greatest common factor of 8x and 8, which is 8. And I know that x times x gives me x squared. And now I'm going to look at 8 and 1x. What's the greatest common factor? My greatest common factor is indeed 1. So I'm going to add both of them together. And how do I know I'm adding both of them together? Well, in my standard form polynomial, I notice that both I'm adding 9x and adding 8. So therefore, my two factors are x plus 8 times x plus 1, and that is indeed equal to x squared plus 9x plus 8. And I can verify that by just looking up and adding up everything together in the area of my rectangle right here. So moving on, let's look at another example. And again, this time I'm looking at example B from our notes today in class. And you're going to notice that this time I have x squared, and I am now subtracting 8x, and I'm adding 12. Noticing that my middle term is indeed being subtracted. Doesn't change anything. I'm still going to be setting up my rectangle. I'm still going to be setting up my diamond. The only thing that I need to note is when I do indeed do my diamond, that my middle term is negative 8x, and I need to make sure that those two numbers that I select are going to give me a negative number. So let's go ahead and make my rectangle. And again, following the same pattern that I've been doing, I've got x squared in my lower left-hand corner, and I can actually do x and x on either side. My last term goes in my upper right-hand corner. I'm going to multiply those two together right like this, and I get 12x squared. So now I'm looking for two values that when I multiply gives me 12x squared, and when I multiply or add, I get me negative 8x. Well, I know that my two factors of 6 and 2 give me a sum of 8. However, I'm looking for negative, so therefore I know that both of them need to be a negative 6x and negative 2x, and I know that it's correct because when I multiply negative 6x times negative 2x, I get positive 12x squared. So now I go ahead and I need to add those two values. I'm going to draw a box around these. I need to add them to my rectangles. And again, I have to decide, where do I want to put them? Well, I can put negative 2x right here. And I can put negative 6x right here on the bottom. And so now I'm going to ask myself, and I'm going to actually use my gold pen here. Take a look. What is the greatest common factor between negative 2x and 12? Well, it's negative 2. Notice that I said negative 2. And I can verify by going x times negative 2 gives me negative 2x. Now I'm going to ask, okay, well, what is my greatest common factor between 12 and negative 6x? Well, it's negative 6. And again, I can verify by multiplying negative 6 times negative 2, and I get positive 12. And negative 6 times x gives me negative 6x. So now I'm ready to go ahead and write my factors. I have x minus 2 times x minus 6, and I know that indeed equals x squared minus 8x plus 12. How do I know for sure? Well, I could always use FOIL and double check, or I can simply count up everything inside my rectangle and it would work. So now what I'd like to do is do example C from today's notes again. And this time we're going to notice something that's different. I've got x squared plus 4x minus 21. And I want you to again notice that, oh, this time I'm subtracting 21 and my second term is adding 4x. Again, what you're going to notice that when I set up my diamond, that my middle term of 4x is positive. So I'm looking for two values that are going to give me a positive 4x. And notice when I do my rectangle and I put my values in, I've got x squared, which means x and x. My last term goes in right here. When I multiply these two together, I get negative 21x squared. So now I need two numbers that when multiplied give me a negative, but when I add them together, give me a positive 4x. Well, I know what are the factors of 21. Well, I know that 7 and 3. I know 21 and 1, right? Well, those are the only two factors. Well, what's going to sum to 4? Right here, 7 and 3. So I need to put 7x and 3x, but I need it to be negative product, but a positive sum. So that means my negative 3 is going to be, or my term is going to be negative 3x, and I'm going to do a positive 7x. So now I'm going to go ahead and I can place both of those numbers inside my rectangle, and I'm actually going to place negative 3x right here and 7x right here. Again, I could have placed it in either box. And now I'm going to go ahead and factor out my greatest common factor. So the greatest common factor between 7x and negative 21 is 7. Notice that it's positive 7. And now I'm going to do it on the bottom. I have negative 21 and negative 3x, which means I have a factor of negative 3 comes out. So I have my two factors of x plus 7 times x minus 3, and that's equal to my standard form of x squared plus 4x minus 21. So I'm going to take us back to this original screen or that I showed you earlier. And you're going to notice that in this case, I've got two positives, and you're going to notice the way it factored out. Notice that one's a positive, one's a negative, that we've got a minus b squared. Then you're going to notice that when I have the difference of two squares, that this is very unique. And so those are the kinds of patterns that you start to recognize. So moving forward, you'll notice on this last problem that I did, I had a positive and a negative. So again, using The box and diamond method is foolproof. It's pretty straightforward. And in the next video, I'm going to actually show how you can use factors, especially when you have these two values being both positive. It makes it really nice and easy to come up with a list of factors that you immediately see. So hopefully you found this video helpful, and please rewatch and stop this as many times as you need and continue to practice based on notes from today.